Hello, dear students. This is Mr. Muhammed Azeez. In this lesson, we're going to start 5.3 to complete the book. This is the last section included for the Wizari exam of 2025-2026. Let's begin. Integration methods. We have two methods to do integration. We have integration by parts, and we have integration by substitution. Integration by parts is commonly known as integral of u dv, and integration by substitution is known as integration u du. Now, let's start with integration by parts. Integration by parts, this is the rule. We have an integral u dv equal to two parts, this is why it's called integration by part, uv minus integral v du. This rule needs to be memorized. You need to know the rule. U dv is the original integral, given integral, that we cannot solve it using the ordinary ways. And here we have uv with no integral, that's directly the final answer, minus an easy integral. This integral is always easy. V du. You can remember the v du part to not mix it with u dv. This is considered like a video game. V du is at the end, u dv is the beginning. We're going to use integration by part. We're going to use u dv in these four cases. For these four cases, we use the integration by part because the question cannot be solved using any other way. But there are other cases where the question is asking you to use integration by part. We'll go to it as well. But these four cases, don't forget, x times sine, x times cosine, x times ln, x times e. These are the cases where we use integration by part. Let's solve the first example, integral x ex. Integral x ex, it's one case of using integration by part. Integral x ex dx. Now I have multiplication of two functions, x and ex, and none of them is the derivative of the other. This is why I have to use integration by parts. For these cases, x ex, x sine, x cosine. For these three cases, we always set u as x for all of these three cases. But in case we have ln, we do set the ln x. If we have x ln x, then we have to set the ln as u, and then x will be dv. Okay, first assumption, x equal to u, and dv equal to the rest. After I took x as u, what's remaining is ex dx. So this ex dx entirely becomes dv. Whenever you write u, immediately write du. By taking derivative of u, du is going to be, derivative of x is 1, and we write dx. This dv is already derivative, so we should do integral to find v. V is integral of ex, and you know ex is a very good function. Its derivative and its integral never change. That's ex. Now we have u, du, dv, v. Let's write a note here. This note is extremely important. The note says, whenever you write du and dv, whenever you write them, we always, du and dv always contain dx. Don't forget that. Whenever I write du, I must have dx in it. Whenever I write dv, I must have dx in it. This note is very crucial. Now it's only about organizing them. Following the rule says integral u dv equal to no integral uv minus integral v du. All right. uv in these four components, this is u, this is v, multiply them. That's going to be x ex minus integral v again du, which is 1 dx, that's just dx. This integral, as I said, it's easy. So the final answer of this integration that cannot be solved using the ordinary ways we learned in section 1, now we can solve it. That's going to be xex minus ex, and there's always plus c, right? And one more note, when we set u dv, u and dv should cover this integral entirely. Look, x is covered by u, and dv dx entirely is covered by ex dx is covered by dv. So u and dv should cover the given integral entirely. Then we can solve it. Now this is the answer. Luckily, there is a fast way. It's not an actual fast way. It's called tabular method, but I'm calling it fast way. That gives some students satisfaction. They feel like, yeah, this is the fast way when I study this. This is not a fast way. That's a really reliable way. You can depend on this way for 3 cases of UDV, but not for ln. The fast way is like this. U, again, use x. dv is ex. For this way, we don't write dx at all. For the part of u, we do derivative. For the part of dv, we do integral. Now, derivative of x is 1. Derivative of 1 is 0. Integral of ex is ex. We stop at the 0. After we finish these 2 columns, this is by turn. We always write plus, minus, plus, minus. If we have more terms, we continue, plus, minus. We always begin with plus. Now, multiply diagonally. If we multiply diagonally, the result of this integral is going to be x ex. Negative 1 times ex is minus ex, and there's always plus c. We got the same answer. Both ways work. Both ways are cool. Now let's solve another example. This example is containing ln. Whenever you see ln, the fast way doesn't work. And remember, always set the ln as u. Don't use the fast way for ln. Let's solve this one as well. Integral x squared ln x dx. If I use the fast way, I won't get the final answer correctly. There will be some missing terms in it. This is why I just recommend to not use the fast way for ln. Again, we're going to set u and dv to cover the integral. Since there is ln, u is going to be the ln. dv is the remaining x squared dx. See? Ln is covered by u, and what is remaining, x squared dx, is dv. Now, for the u, we find du. Derivative of ln, obviously, is 1 over x. Don't forget to write dx when you do du. And integral of dv is going to be v, the derivative. D stands for derivative. When we do integral, the derivative gets cancelled. V is integral of x squared, which is x power 3 over 3. No need to write plus c. Now, we just apply the rule. Integral u dv equal to uv minus integral v du. Now, uv, uv, multiply them. X power 3 over 3 times ln x. Order doesn't matter. It's multiplication, so I can write vu ln x minus, always the integral part is easy, v du. V is x power 3 over 3 multiplied by du is 1 over x dx. There's a bit of cancelling. This 3 becomes 2. This x cancels out. Now what's remaining is x power 3 over 3 ln x minus, here I have x power 2. Integral of x power 2 is x power 3 over 3. Don't forget this 3 down is division. Division won't cancel. Division stays. The 3 stays. This 3 is the result of integration, x power 3 over 3, and this 3 just stays. And there's always plus c. Now 3 times 3 is 9. I can just write x power 3 over 3 ln x minus x power 3 over 9 plus c. This is how you do it. Zoom out, you can see the whole thing. Yeah, there you go. This is how we do UDV. This is what students are afraid of. You just need to understand it. You just need to know how to deal with it. Panic won't solve anything. Okay, now integral Linux. Integral Linux, it's a rule. The rule is written here. Write it somewhere. This is the rule. And you need to know the rule. You need to memorize it. Integral of Linux dx is equal to x Linux minus x plus c. Integral of Linux is x Linux minus x plus c. Just memorize this rule. Now let's apply the rule to solve this integral. Integral of ln x is going to be x ln x minus x, and this integral is definite integral. So once we input e, once we input 1. Now when we input e, this part, this calculation is 1. 1 times e is just e, minus. This e stays the same, minus. Ln of e is equal to 0. So this part is completely 0. Gone. What's remaining is negative 1. E minus e is 0. Negative 1 will be positive 1. And the rule I just mentioned works even if there is a number inside the ln. Write this as a note. Integral ln ax dx is going to be x ln ax minus x plus c. So if we have a number multiplied by x inside ln, then it's going to be like this. For normal ln, it's going to be x ln x minus x, but if there is a number multiplied by x inside the ln, look, ln x becomes x ln x minus x. If a number is multiplied by x inside the ln, the number will be multiplied by x inside the ln in the result as well. So these two lns in the integral and in the result are the same. Now, since we know this note, solving this ln question does not need UDV, so we can simply just cross this out, because we know ln 3x becomes x ln 3x minus x, as it's written here. Until here, you can cross the solution out. We don't need this. We don't use this way. Ln 3x becomes x ln 3x minus x. Once we input 3, once we input 1. A question similar to this came back last year in 2025 second trail, but unfortunately the question was right, but the choices were not right. Students got the 2 marks back. Now, we put 3 in place of x. That's going to be 3 squared. And power goes down in ln. And here, ln 3 minus 1. Result. Finally, the result is in terms of ln. This is the end of this session. Thank you so much for watching. Next lesson, we're going to explain UDU, and we solve some more exercises about UDV. Thank you for watching.